here is how your project should be structured overall, right? So the first thing that you do is you download a piece of Facebook and load it from Stanford Large Network Dataset Collection, and then you load it into Python. Then you need to think about an event that people usually get to know about from Facebook, and so the event must be something that will can be observed in Google Trends, right? So then if you go to Google Trends, then you should see that this trend, it goes up and then steadily goes down, right? So the event is anything that you want. So I thought of Leave Family Saga because it was originated in Facebook, but you can pick something else. It doesn't really matter what you pick. I don't know. So any real story that you want to look at and you want to model can be your choice. So then the logic here is that the real piece of Facebook that we have is 4,000 nodes. It may be too large for, well, to be honest, it is not too large to simulate spread of information just once, but since we want to simulate spread of information for many pairs of P and Q, so that we can find the optimal choice of P and Q, and then it may be too large for that, right? So, which is why we want to create a small version of this real network that still captures most important properties of Facebook, right? And then we're going to simulate spread of information over that small toy model of Facebook rather than over the actual Facebook. And then we need to feed parameters of the model into real data from Google Trends. So the work on the project is going to take several weeks. Weeks 9 to 10 of the semester will be devoted on learning the basics. So on week 9, we will be in computer labs, of course. So if you want to come to computer labs, you can. So then if you come to computer labs, then we will help you to read these Newman's papers and all that, and help you with, I don't know, understanding the MDA model and the SIR model and so on and so forth, right? So, but if you do not want to come to labs on week 9, it's really up to you. You don't have to. On week 10, by the end of week 10, you are supposed to have very good idea of the task distribution within the team, and ideally you should have working routines for the most complicated tasks for the MDA model of a random network and for the information spread of information over the network, right? And on week 10, during class, the course instructor is going to meet with each team and to discuss the distribution of tasks with them, right? So which means that on week 10, you should come to class, maybe not for the whole class, but there will be some timetable. So you will have 10 or 15 minutes to talk to your course instructor. Okay, so on week 11, what you do is you work as a team. So you need to discuss which random model is best to represent Facebook, which event you want to research if you haven't decided earlier. All right, so then load Google Trends data into Python and then feed parameters of the model into data. So this is kind of, so notice that when you write a routine for simulating SIR model, the spread of information over a network, this can be done independently. I mean, you don't have to do it for this specific network that you're going to choose. So the outcome of that is going to be a function whose input is a network and whose output is the number of infected nodes day by day. All right. So that function should be ready by week 10. So that on week 11 you can apply this function to you can give the real data to this function, and you can use the feed the parameters of the model into data. So on week 12 you're going to put everything together. slides and the final report, right? Then again, so on week 11, I don't think that it makes sense to come to class on week 11. You can still, I mean, we will be in class just in case, but you don't really have to. On week 12, if you want the instructor to look at your slides or to look at your report and give you some informal feedback, then you should come to class on week 12. So on week 13, there will be actual presentations. So each presentation takes 10 minutes. That there will be a certain schedule, right? Then if you want to attend other teams' presentation, you can, but you don't have to. Then the course instructor will grade your presentation and give you the kind of more official feedback. It is not the final grade is not the official grade yet, but you can look at the feedback to improve your final report, right? So then maybe one more thing that I should mention is that when you do this presentation, it is important to understand that the audience is going to be instructors and students, and both instructors and students are probably familiar with Erdős-Rényi model, Watts-Strogert's model, Barabás-Albert model, and so on. So in the presentation, you do not really have to emphasize the constructions of those models because everyone knows it. So in the presentation, you need to explain the findings, and you need to give us some good impression of what special things you have done that other teams probably haven't done, right? But in the report, everything should go into the report. So if the definition of the Erdős-Rényi graph, short description should be in the report. So the short description of the Watts-Strogert's graph should be in the report, and so on, right? And then during the study week, you can update the final report based on the instructor's feedback. Right, so the idea is that after your presentation, you have one more week to finalize your report and submit to NTU Learn. Right, so the deadline for submission is 1 week after the week 13 lab session. So then if you need an extension for the deadline, please talk to me. I guess it can be arranged if, say, you have a lot of classes or other deadlines during the last week of the semester. We can probably postpone it a little bit. So, but the way I see it now is that 1 week after the lab session. So the Monday group, the deadline is on Monday recess week. So the Monday study week. Wednesday group, the deadline is on Wednesday study week. So there are some technical requirements, like 6,000 words. Last year, instead of 6,000 words, we had 8 pages, I think, or 10 pages. But with Jupyter Notebook, it is very hard to predict the number of pages, and it's very hard to control like size of pictures. So I decided to change that to 6,000 words. Okay, but it just means that you should be when you explain all your findings and all the models and so on and so forth, you should try to be brief but precise. Okay, so 6,000 words is not too much. Believe me, it's not going to let you, I don't know, write a book. So it is just enough to present all the findings. Then the report must contain the certain parts. Then how you name these parts is up to you, but it is important that the order should be the same, because imagine that I have to grade a lot of these reports, and I want to make sure that everything is present in your report, right? So imagine that if, say, you explain one model in the first part, then you, I don't know, work with Facebook, and then SIR model, so the spread of information, and then you introduce another a random network model. So then it's just too hard for me to browse through your report. So then to make it easier for the grader to grade your report, you must make sure that all the parts are in this order. I understand that it probably you think that it restricts your creativity, but it is for the best of everyone that we should stick to this order. So first abstract, so then there should be an overview of all the random networks that you are that you have learned and that you want uh, to present in your report. So model in Facebook, where you compare properties of random network models to properties of Facebook and choose the model that represents Facebook best of all. Then the model of spread of information. So you explain how it works. Then you explain what your event is. So maybe give us some background. Load the data, plot the Google trend in Python and so on. Then there should be some extras. So if you want to do something related to the project, but that does not really fit into any of these sections, then you can introduce a new section called extras, or something like that. And then you whatever you want to share with us, you can put it there. And in the end, there should be a reference list. So it is extremely important to explicitly cite everything that you've used in your work. It includes pieces of research or exploratory papers, like that Newman's big paper that you're going to read for your project. So you should cite them explicitly. But not only that, so data source, so Stanford's dataset collection, you should cite it. Google Trend, you should cite it. So if you are going to, so imagine that the mediation-driven attachment model, if you just Google, if maybe someone has already implemented it in Python, and if you want to reuse their codes, then you should cite it explicitly. Or if you want to build on the work of your seniors, then you should explicitly cite your seniors' reports too.